Hello students. Okay. Here's our problem. We need to find these double angles, sine 2 theta and cosine 2 theta, given that the tangent of theta is 12 over 35 and theta is in the first quadrant. So that means that sine and cosine will be positive. So I've written some identities. Tangent of theta is sine over cosine theta. I have the Pythagorean identity, sine squared theta plus cosine squared theta equals 1. And I wrote down the double angle identities here and here. So you might be wondering, why did I write sine squared theta plus cosine squared theta equals 1 when I already have the sine theta and cosine theta? Well, that would not be true. I do not have the sine theta and cosine theta because remember, if you were to think that the sine theta were 12 and the cosine theta were 35, that would be incorrect because remember that sine and cosine must be less than or equal to 1. So we have to divide these by whatever the radius is in the first quadrant. And we could determine that radius using this identity. Alright, so let's plug these in. So that means, when I say plug this in, what I mean here is that the sine theta is equal to 12 over r, and the cosine of theta is equal to 35 over r. Okay, so sine squared of theta is really the sine of theta squared, and we already said that that's 12 over r, plus the cosine of theta squared, and that's 35 over r, quantity squared, equals 1. And now I have an algebraic equation that allows me to solve for r. So that'll be 144 over r squared plus 1225 over r squared is equal to 1. And that is 1369 over r squared equals 1, and that means that 1369 equals r squared, and since I'm looking for a radius, I only need the positive square root, and that gives me r is 37. Alright, so that means for us that the sine is really 12 over 37, if I could fit that in there, and the cosine is 35 over 37. Alright, so now I can just calculate simply sine 2 theta. The cosine, recall, is 35 over 37. And the sine of theta is 12 over 37. And let's see, that would give us that 840 over 1369 for the sine of 2 theta. And the cosine of 2 theta is, let's see, the cosine, once again, is 35 over 37 quantity squared minus 12 over 37 quantity squared. And if we work the arithmetic out, we get that the cosine of 2 theta is 1081 over 1369. So hopefully I got these computations correct. I believe I did. And that is your solution. All right. Good luck.